Welcome to this section on network forensics. So today, when attackers operate stealthily over networks, being able to investigate what actually happened during or even after an incident is a critical skill. So previously, we've already discussed things like cyber kill chain, incident response lifecycle, intrusion detection. But another very important skill in the arsenal of cybersecurity specialists is the ability to analyze logs, capture packets, and find traces of threats, attacks, and malicious code. And this is what this section will be dedicated to. So network forensics refers to the process of collecting and analyzing network events for the purpose of information gathering or intrusion detection. Now, a couple of important terms. The first thing is collecting. So before you can actually go ahead and analyze an attack or a log, you need to first collect it. And as we're going to discuss in this lecture, there are a couple of different places where you can get these type of logs. The next step is actually analyzing. And there are some very popular tools like Wireshark, which we'll also cover in this section, which help you dissect the network traffic and exactly understand what's going on. And the final aim is that we want to gather information as to what's going on and possibly detect any intrusion. Remember, network forensics forms a vital part of both proactive threat hunting as well as post-incident investigation. Let's see an example. So let's discuss the SolarWinds attack of 2020. So SolarWinds is a big player in the software world, and it suffered an attack that began in September 2019. So many of SolarWinds customers used a system called Orion provided by SolarWinds, which was basically a performance monitoring solution that tracks the status of SolarWinds Orion customer. And attackers targeted this particular software, and they basically inserted malicious code. So in September 2019, hackers were able to access the SolarWinds network, and soon after that, they started testing their code injection in Orion. Couple of months later, after they had done all the testing and they were happy with the results, they injected malicious code called Sunburst into Orion. And as a result, on March 26, 2020, 18,000 customers of SolarWinds, they ended up installing updates with the malicious code. And please bear in mind, among these 18,000 organizations, it also included US government agencies. Now, this was one of the largest cyber attacks, but what we want to discuss is how network forensics helped uncover as well as mitigate this attack. So network packet captures helped uncover unusual outbound traffic from infected systems. And then forensic analysts traced the command and control communication, which revealed a data exfiltration pattern. Without deep packet analysis, the attack might have remained hidden much longer. So by leveraging network forensics, they used network logs to help discover one of the biggest cyber espionage campaigns in history. This highlights the importance of network forensics and the ability to capture, analyze, and then action logs. Now, the first thing that you need before you go ahead with your forensic analysis is network evidence. There are two broad categories of evidence we rely on in network forensics. So the first category is network traffic analysis. This includes full packet captures using tools like TCP dump or Wireshark. So here we are referring to traffic that is actually flowing. We capture that and then we try to use tools like TCP dump or Wireshark to analyze the headers as well as the content of those packets. The second type of network evidence is log analysis. And these logs can come from routers, proxy servers, web servers. Now, these two are not mutually exclusive. In fact, these two types of network evidence, they complement each other. The network traffic analysis gives you the raw, real-time data, while logs give you summarized, retained data. Now, let's dive a bit deeper in network traffic analysis. Now let's clarify some definitions first. So what's packet sniffing? Packet sniffing refers to looking at network packets as they traverse the network. And what are packet sniffers? So a packet sniffer is a tool that lets us see data packets as they traverse the network. Kind of like wiretapping for the digital world. It gives you detailed header information as well as payloads, depending on how the traffic is encrypted. And these can be command line or GUI based. Some popular packet sniffers that we're going to discuss in this section are firstly TCP dump. So this is a command line tool that's very fast and very scriptable. So basically you can include it in a lot of scripts and it's very widely used. So this analyzes all types of network traffic, and you can even be very specific if you want to, for example, listen on a particular port, a particular type of packet, a particular protocol. The second one is Wireshark. This one is a very powerful GUI based tool which helps you dissect network traffic in a lot of detail, and it has a bunch of built-in tools which facilitate the task of forensics. Wireshark is one of the most popular tools for network forensics. We also have Ethereal, which is sort of like an old name for Wireshark. It evolved to Wireshark. Now you need to understand how packet sniffers get a copy of the traffic. So the way that packets traverse over a LAN or a local area network or a subnet is that the packets don't just go from one computer to another. So for example, let's say if system A wants to send a packet to system C. Now if you notice, the destination IP address is 3.3.3.3 and source IP is 1.1.1.1. Now it doesn't happen that A sends a packet and it goes directly to C. The reason being that a packet is just basically electromagnetic signals traveling on this wired network. Okay? So there's no sense of sort of direction for the packets or the signals per se. Now the way this works is that A basically generates these signals or sends this packet, and everybody, because they're hooked onto this line, they also listen to this packet. Now what actually happens is that once these systems have received these packets, for example, let's say B also received this packet, so it's going to see, is it my MAC address? No. So it's going to discard it. Similarly, D is also going to compare its own MAC address to the MAC address in the packet, and it's going to discard it. And then C, it checks that it is, yes, this is for me, C. So it's going to pass on this packet to the upper layers. Now, how packet sniffers work? So let's say you put a packet sniffer here. Then this packet sniffer is also going to receive its own copy. Just like B, C, and D received their copies, this sniffer also receives a copy. However, this sniffer is programmed or configured to listen in promiscuous mode. What does it mean? It means that regardless of whatever MAC address it has. So for example, let's say this sniffer has the MAC address, and it checks that, okay, is this my MAC address? It doesn't match. Even then, it doesn't matter. Sniffer is still going to send this packet to the upper layers for capturing and analysis. So that's the key difference. Normal stations or normal end computers or servers, they're going to check their own MAC address before deciding whether they should process this packet or drop it. However, sniffers, they operate in promiscuous mode. They are going to ignore this check and pass on the packet anyways. And that is exactly how network traffic is captured. So normally what organizations do is that they don't want all of the systems listening on one line like we just discussed. So what they use are called switches. And a switch's job is to make sure that traffic for a particular destination is only sent on that segment. For example, let's say this is A, this is B, this is C, and this is D. Now, if A wants to send to C, the job of this switch would be to make sure that it switches this traffic only to C. Similarly, if B sends to D, then switch is going to send the traffic to D. Now, this is different from what we just discussed. In that one, we just had everyone listening on the same line. But organizations don't want to do that because that creates a lot of collisions, a lot of traffic on one segment. By using switches, you can more efficiently separate out the traffic on different segments. Now, in this case, how would the sniffer receive traffic? Well, so a lot of switches provide this feature, which is called switched port analyzer, which has a dedicated port on the switch. So for example, whenever any traffic passes through this switch, this special port, this dedicated port, makes sure that a copy is sent to the packet sniffer. And besides packet sniffing, by logging a copy of the traffic, it also helps in troubleshooting. So now one of the most popular tool for packet analysis is TCP dump. It's a favorite tool among professionals. It's really fast, it's easy to script it, and it's great for automation. Now, the way this works is that it uses different libraries depending on which operating system you're using. So for example, if you are on a Linux-based systems, then it's going to use the libpcap, which is the capture engine for Unix-like systems. If you are on Windows, it's going to use winpcap. And there's also an additional variation or slightly more advanced version, which is npcap, which is again a port of this library. So this library is the core library. It was designed for Unix-based systems, but later it was ported to Windows as well. Now this library operates at the driver level and allows applications to read packets raw from the network interface card. While packets are great for detail, logs are often more practical in real-world investigations, especially when you don't have the full captures. So logs can come from a number of sources. They can come from web servers to analyze browsing history or access attempts. They can come from proxy servers to review outbound requests. They can come from firewalls to trace blocked or allowed connections. They can also come from DNS and DHCP servers, which basically correlate the host names and IP addresses. And for analyzing these logs, we again have a bunch of tools. We have SolarWinds, we have Splunk. So just keep in mind, for the network traffic analysis, we had tools like TCP dump, Wireshark to analyze. For the log analysis, we correspondingly have different tools such as SolarWinds or Splunk. And Splunk in particular is a very popular security incident and event management tool, which allows you to correlate logs across multiple sources. To sum it up, network forensics is both a science and an art. It requires attention to detail, tool knowledge, and the ability to reconstruct events like a digital detective. So whether it's analyzing full packet captures or logs, your goal is the same. Trace the attack, understand how things evolved, how it happened, and possibly identify who might have been responsible, or at least how did they break in. In the next lectures, we're going to explore these concepts as well as these tools in more detail.